All right, and we're back, and it's good to be here. I am losing track of it, but I think we're already on Parabolas Day 3. So let's get to it. We are on the Conics Sections packet, page 36, and we're about to look at the bottom of it. I'm going to scroll down to where it says 10-2b down here, so we can look at a few examples. And I have a joke for you. It's been a while, and I think this one came from a Laffy Taffy wrapper. So, guys, guess what? I burned my Hawaiian pizza. I guess I should have set it on aloha temperature. All right. Moving on, looking at parabolas, these examples at the bottom, starting with number one. So first, good warm up. Just get yourself into it. Let's try number one. We're given a couple features of a parabola. Focus is at 3, 0, and the distance from vertex to focus is 2 units. Okay, so that gives us a lot. It also says, we haven't really seen this before, the parabola has a minimum. And we know what a minimum of a function is. It's a low point on the function, but this should tell me the orientation of that parabola. I don't think a parabola that opens down, right, or left is going to have a minimum. The only way I see a parabola having a minimum value is if it opens up. So already I know I'm dealing with an x minus h squared, right? X is going to be squared if the thing opens up. And I already know what p is as well. That p is going to be positive 2. It says the focus is at 3, 0, so you're up 3, or I'm sorry, you're over 3 on the x-axis. And the vertex, distance from vertex to focus is 2 units. So we'd have to travel 2 units up to get to that focus point. That means 2 units down could get me back to the original vertex, right? It's going to open, kind of missed it there, up from there. So now I've got what I need. I've got the h and the k. The vertex is 2 down from the focus at 3, negative 2. And what do we say? X is squared here. So x minus 3 squared. The 4p goes on the other side. I'll just put 4p, even though I think we know that as well. And then y minus negative 2, so y plus 2. And then that distance from vertex to focus gives us a 2 here to make that coefficient an 8. So your standard form has 4 times 2 is 8, and then y plus 2. Okay? All right, now let's look at something new. The second one and the third one say, yikes, we're given an equation of a parabola in general form, and we want to get it back to, let's make this bigger here. We want to get it back to standard form so that we can find everything: vertex, focus, directrix, axis of symmetry. What I'm hoping is this is just as quick as it was with ellipses and hyperbolas, and maybe even a little bit quicker, because with parabolas you only have the one squared variable, so you only really have to complete the square once. Your rule of thumb is you're looking for standard form. So focus on the squared variable and keep stuff that has to do with y on the left-hand side. Everything else moves over. So the y squared and the 6y, I recommend keeping those on the left. Leave a space to complete the square. I don't know if we're doing it in this step or later, but everything else, constants, x terms, anything that's not involved with y is going to move to the other side. So we'll add an 8x to the other side and subtract a 65. So all squared term related things and all other terms get dumped over to the right. Now it's time to complete the square. I just found out I can change the pen color to purple. I think I knew that already, right? Didn't I? I want to add half of b squared to both sides. So half of 6 squared, I want to add a 9, and I'll add a plain old 9 since I wasn't really multiplying by anything else out front. Now we can factor. So let's factor the left side, y plus 3, y plus 3. And the right side starts off as 8x minus 65, we'll say plus 9. So just add those up, you get minus 56. Then for our version of standard form, the side with the linear variable needs to get GCF'd. And actually, not really GCF'd, but whatever number is sitting out front of the x needs to get factored out. So it's y plus 3 squared, and 8 comes out, and then you have x minus 7. And then you can easily see, oh, and I want to try this cool trick again, a circle around my standard form. That looks okay. And I can easily, if somebody needs it, I could easily give them the vertex, focus, directrix, and axis of symmetry. So let's just list those coordinates. Vertex, right? H comma k. Focus, well, I would need p for that, right? In this one, 4p equals 8. So p should be positive 2. If we were to graph this, you could probably tell which way it's going to open now. You know it's some kind of sideways. It should open to the right if p is positive. So focus is going to be 2 units to the right. So 7 plus 2, we'll just write it as a 9, negative 3. We're moving to the right. And then directrix. an axis of symmetry, AOS. Okay, like that. Axis of symmetry is kind of quick because I always say you just look for the shared variable, and here both of these important points have a y coordinate of -3. And the directrix always falls perpendicular to that axis of symmetry. So for the directrix here, we got to think, well, if I looked at a picture of this, you went 2 units, what did I do? 2 units to the right of the vertex gave me the focus. So I added 2 to the x. 2 units to the left of the vertex should give me the directrix. If this x coordinate was at 7, this one here should be 2 less than that. It should be at 5, and it's a whole vertical line at x equals 5. If graphing it helps, go ahead and sketch a graph. If you can figure it out just from the numbers, go ahead and do that too. All right, I'm going to bounce myself over so that we can try number 3. If you want, this might be a really good time to just pause the video, try 3 on your own, and then just turn it back on to check your work. Let's complete the square. So actually, let's move stuff around. So squared term this time is the x. I'm going to leave all x-related items on the left with a space, and everything else moves to the right. 40y. Nice sunny day we're having today, isn't it? And how did I do with the signs while I was talking? I add the 40y. I think I also got to add the 4 here, so plus a 4. Now, I cannot complete the square with that 4 out front. So never fear, we're going to factor it out. And I see my other mistake. This was a 24x. So let me try to be a little bit neater and more careful about this. 4 comes out, and are you guys getting x squared minus 6x like that? Leave a space so that you can complete the square. On the other side, I wouldn't GCF or do any factoring to it yet. I would wait until we see what we need to add to this side so we see everything that we're working with. So I want to add half of b squared, happens to be a 9 again inside of parentheses, and I add a 9 here too, right guys? Wrong, right? You're adding a 36 because it's 4 times 9, so plus 36. So we've got 4, we've got our factored trinomial, so x minus 3 quantity squared, and then 40y plus 40, like that. 2 things need to happen. The 4's gotta move. I would do that next, and then the last step is to factor out the right-hand side. So divide everything by 4. X minus 3 squared. We want this spot to be free of any non-1 coefficient. And 40y divided by 4 is a 10y, and 40 divided by 4 is just the number 10. And now we can find the 4p if we pull out the 10. And I'm running out of room a little bit here, but we'll see if we can squeeze everything in. 10y plus 1. Okay. Which way does this thing open? Up, down, left, or right? Did we talk about that yet? We see x is squared, so our choices are up and down, and we see p is positive. So we want to open up toward the focus. And vertex comes first. So vertex, we'll say, is going to be h comma k, 3, -1. Focus, let's use p for that. So 4p equals 10. And p should be 2.5, right? 5 halves. So we want to travel in the positive direction, 5 halves from the vertex. So you're at 3, -1. You want to add 2.5 to -1 to get 1.5. I'll put it as a decimal, just 1.5, like that. All right, directrix in axis of symmetry. I usually do this out of order. And since it's pretty quick to look for the axis of symmetry, sorry, this is so sloppy, look for the shared coordinate. These fall vertically, one right above the other at x equals 3. And so x equals 3 would be a great axis of symmetry for that. Directrix, it'll be a y equals. It's got to run perpendicular. Think of how far you traveled to get to the focus. You went 2.5 units up to get to the focus. We've got to go that same distance, 2.5 units down to get to the directrix. So look at your original vertex y coordinate, and can you go 2.5 down from there to -3.5? And this problem is finished. Okay, ooh. Okay, let's turn the page. All right, what's going to be over here? 4 is a really good one. Where should I go for this one? I guess I'll go down to the side. Axis of symmetry is vertical. Okay, so I always get curious about why they gave us that info. And the parabola passes through these 3 points. If it helps and you want to sketch those 3 points, it might give you a good sense of what this thing looks like to start off with. But we're just going to use a lot of algebra here rather than a ton of graphing. So my sketch is going to have a point at 0, 0, 3, -2, and then -1, -2, so down here. I mean, I see a parabola that opens downward. It makes sense to me that that axis of symmetry is going to be vertical, but it's still good information. We don't know where the vertex is. We know a good bit about symmetry, but if the axis of symmetry is vertical, we know that this is an equation where x is going to be squared and not y. And this thing should, it looks like it's got to open down. If these are the way the points are going to go, it'll probably come up through here and down through there, but not miss all the points. Oh, okay, just forget that just happened. Please just delete that from your memory. Let's start from general form of the equation of a parabola. Now, usually you have an x squared and a y squared in all the other conic sections, general forms. In parabolas, only one term is squared, either the x or the y. Let's just keep the x squared if we want this thing to open vertically. So x squared plus, I'm going to skip the y squared term. I'm just going to make c 0. And I get dx, and I need my ey term that could be present, and the f term. And can you anticipate what we're about to do? Because we did it with circles and ellipses, and I don't know if we did it with hyperbolas yet, but we could have. We can make a system of equations. Start with the point 0, 0. This should give us one answer for free. Plug in zeros for the x's and the y's, and we should get f, right? This should give us 0 squared plus 0 for x plus 0 for y plus f equals 0. So no need to really worry about the f value. Next point is 3, -2. You're going to plug these in carefully for x and y. So I will switch to green, and x squared comes first. So 3 squared is a 9 plus dx, so plus 3d, right? X is 3. Plus ey, so minus 2e, e times -2, plus f, but that's just plus 0. I'll use what we already know, equals 0. This isn't solvable for either d or f, but it is a workable equation that we could use later in the system. So 3d minus 2e should equal, we'll just say here, -9 if we move that to the other side. I'm going to save this for later. And there's one more point to plug in. Can you try -1, -2 plugged in for x and y? -1, -2. So -1 squared is 1 plus dx, so minus d times -1, minus 2e plus 0, because that's f, equals 0. And you could say I'm just going to move the letters to the other side. 1 equals d plus 2e. And that works really nicely in a system here. If we use both of these, I'll just swing this up to the top. I might have to move myself around in a second because the two e's are opposite signs if I write them one above the other and if I want to just use elimination. 3d minus 2e equals -9, and then d plus 2e equals 1. It's a great day to solve a system by hand. I'm admitting that I could be using the calculator and a matrix here, but it's just, it's a nice day to solve a system by hand. Let's get rid of those, make it 4d equals -8, and we get our second solution, d equals -2. Okay? And then third part of it, we have to find, what am I missing? E. So pick either one of these equations. I'll pick this one and say 1 plus 1 equals, whoops, we'll say 1 equals here, delete. Okay, I got rid of my arrow too. So 1, try that again, equals d, so -2 plus 2e. And we'll solve that for 2e. So 3 equals 2e. And then e is 3/2, 1.5. Okay, I sort of ran out of space here. I guess I could use the space where I was sitting. You're going to plug into general form. So let's plug back in what we just got for d, e, and f. Into general form, it'll be x squared. D was -2 minus 2x. E was 3/2 plus 3/2 y plus 0 equals 0. So here's your equation in general form. And then you're going to take it from there. You can leave the x squared and the 2x on the left side, complete this square. You've got to move a -3/2 x to the other side, or a -3/2 y, I should say. And you're going to do the work from there. Complete the square, GCF out whatever's on the other side. You might have noticed I just slipped in the set of answers here for you to be able to check your vertex, focus, directrix, axis of symmetry with when you're done. Okay, happy solving, and until next time, see you later.